Okay, so far we have learned that factorization is the opposite process of simplification. In factorizing, we want to create brackets, whereas in simplification, we want to get rid of brackets. So far, we have learned two types of factorizing. The first one is a common bracket, in which we had normal terms we could take out, but we also learned how to handle fractions and also common brackets. In the second one, we learned how to apply a difference of squares, where we'd have two terms, both of them would be squared, and there had to be a minus between them. In such a case, we're going to create two brackets, put a plus in the one bracket and a minus in the other bracket, and then we put the square root of the first in the first positions and a square root of the last guy in the last positions. The third type of factorizing that we're going to learn about is called a sum or difference of cubes. I refer to these ones as SOP sums. SOP stands for same, opposite, plus. What do they look like? In this kind of a sum, it doesn't matter if you've got a plus or a minus. But again, you need two terms, of which the first one needs to be a cube, and the last one also needs to be a cube. So this is a sum or a difference of two cubes. If this happens, you're going to open up a small bracket and a big bracket. We'll have a binomial in the first bracket, and we'll have a trinomial in the second bracket. Now what we do is we are going to spell SOP with our signs. We're going to put the same sign here, the opposite sign there, and always a plus in the last position. So that's where the SOP comes from. Same, opposite, plus. We will now take the cube root of the a cubed, which is a, and immediately we're going to square it in the first position, a squared. Then we take the cube root of the last guy, and we're going to immediately square it in the last position. Then we take the product of these two guys, and we put that in the middle, AB. What did I do there? Let's do another example and see if you can follow on this one. This is a sum or difference of two terms of which both are cubes. All right? One is 1 cubed, and each of these exponents is divisible by 3. So they're definitely both cubes. We'll open up a small bracket and a big bracket. Spell SOP with your signs. Same sign, opposite sign, always a plus. The cube root of this first term over here will be x cubed y to the power of 5. See, I basically divided the exponents by 3. Then I immediately will go and square that in the first position. So x cubed squared will be x to the 6, and y to the 5 squared will be y to the power of 10. Okay? Notice that if I multiply x cubed y to the 5 with x6 y to the 10, I still need to be able to come out with this very first term over here. The cube root of the second term is 1, and immediately I square it here to give you a 1. And now I say the first term times the second term in the middle. 1 times that just leaves me with an x cubed y to the power of 5. One more example of an SOP sum. How about we take 8 minus a to the power of 6. Okay. 8 is 2 cubed, so that's a cube. A to the power of 6 has an exponent that is divisible by 3, so that's also a cube. Hence, I can open up a small bracket and a big bracket. Same sign, opposite sign, always a plus. The cube root of the 8 is 2, and immediately square it in the first position. The cube root of the last guy is a squared, and immediately square it in the last position, a to the power of 4. Now we write down the product in the middle. So 2 times a squared is 2a squared. Got it? The next type of factorization we need to deal with is a trinomial. Now there are 2 types of trinomials, so I will actually refer to them as easy trinomials and tough trinomials. Let's do the easy ones first. What would qualify something as being an easy trinomial is when our leading x squared, or our leading variable, or not variable, our leading coefficient is a 1. So let's take something like x squared plus 3x plus 2. See, the leading coefficient of this term, the very first term, is a 1. And if it's a 1, we can call it an easy trinomial. How we would handle this sum is we are going to take the factors of the last guy. What times what would give you 2? 1 times 2. If there were more options, you'd write those ones down also. Ultimately, though, I want to come out with a positive 3 as an answer. So to get a positive 3, I would have to say plus 2 plus 1. Do you agree? And therefore, I would get x plus 2 and x plus 1 as my brackets. Let's try another one. X squared minus 6x minus 16. All right. What we're going to do is we're going to take the factors of the last one. 1 times 16, 2 times 8, 4 times 4. Which of these combinations would give me an answer of negative 6? Does 1 and 16 work to give you a negative 6? Nope. How about 4 and 4? Would that work to give you a negative 6? Nope. But 2 and 8 will work to give a negative 6. How does it work? We'll take a negative 8 and a positive 2. And therefore my brackets will become x minus 8, x plus 2. Easy, right? Just to convince you that it is correct, let's take a pencil and just multiply these brackets out. And if I'm right, I should come to that previous step. X times x is x squared. X times 2 is plus 2x. Negative 8 times x is negative 8x. And negative 8 times 2 will give you a negative 16. If I now add like terms, I get x squared minus 6x minus 16. And therefore, yes, I'm correct. Does that make sense to you? So we take the factors of the last guy that will give us the middle guy. Let's try another sum. x squared minus 5x minus 6. Now this one's a little bit trickier than the other ones have been. Again, we are going to take the factors of the last one, 1 and 6, 2 and 3. Again, I want to get an answer of negative 5. Which combination would work to give me a negative 5? Well, here I've got a choice. I can either say minus 6 plus 5, or I can say minus 2 minus 3. Both of those would give me an answer of negative 5. Agreed? So how would I know which one I'm going to choose? For that, I look at the last sign, which in this case is a minus. And if it is a minus, I'm going to choose the option that uses opposite signs. Right? So I want to choose the option that is going to have opposite signs. Plus 1 and negative 6 are opposite. My answer here is going to be x plus 1, x minus 6. You got it? Now let's suppose my sum actually said x squared minus 5x plus 6. In that case, I would have chosen to use the combination that has the same signs. So I would choose to use x minus 2 and x minus 3. Well, I should have written that in red. Let's do that again. So it's x minus 2 and x minus 3. You got it? So if the last value is a negative, make sure that your brackets have opposite signs. And if the last value is a positive, make sure that the brackets will have the same signs. All right, so those are the easy trinomials. And up to now, everything has been fairly straightforward. What I'm going to do with you now, however, is the tough trinomials. Now, tough trinomials, there are many methods out there. I've heard of the tennis court method, I've heard of the peanut method, I've heard of inspection method, and the others fail me at this stage, but there must be about 5 to 6, maybe even 7 methods out there. I've been doing this a long time, and it is a very rare case that one of my students will come to me knowing how to do these things. They would have learned some kind of a method from somewhere. It wouldn't have made sense to them. They kind of fiddle around in the dark with it, but they don't get to the answer, and they definitely don't get there fast enough. So if you struggle with these, I suggest forget everything you have learned about tough trinomials until now and do exactly what I say. It is a guaranteed method. However, you need to practice it. If you practice them immediately, you will get them right and never ever forget them. But if you wait a while, you're probably going to forget it, and then you're going to have to come listen to the video again, and then you're going to get confused, and so on and so forth. So why am I going to this big elaborate speech before doing one of these sums? Do exactly what I say, even though it looks like a lot of work. I promise it isn't. And practice them as soon as we are done so that you can master them and get it into your head, concrete it into your head. All right? Let's start. 6x squared plus 7x minus 20. Now, what qualifies this guy as being a tough trinomial? He has a leading coefficient that is not a 1. So had that been a 1, it would have been an easy trinomial and we could have done the easier method. But this is not a 1, and therefore we're going to follow the tough trinomial method. I call it the sausage method. We're going to start by writing down all the factors of the first guy. 1 times 6, 2 times 3. Then you're going to take all the factors of the last guy. 1 times 20, 2 times 10, and 4 times 5. See how I write them down almost like little fractions? I'm writing down the pairs that are factors of those two numbers. Okay. Now what we're going to do is we are going to choose the two that are closest together. That means that 2 is closer to 3 than 1 is to 6. And 4 is closer to 5 than 1 is to 20. We are now going to do some brain work. We're going to look for a combination that is going to give us an answer of positive 7. If I said 2 times 4, I'd get 8. 3 times 5 gives me 15. Would 8 and 15 work to give me an answer of 7? Yeah. So we found our pair. Now comes the secret sauce. Write it down like a baby. 2 times 4 equals 8. Notice these gaps I've left over here. 3 times 5 equals 15. You want to come out with a positive 7, which means you need a positive 15 and a negative 8. Transfer those signs to the front, minus and a plus, and now you're going to put your sausage in. So the multiplication sign is now a placeholder for your x. And we're going to put this funny little sausage in. 3x minus 4 and 2x plus 5. You're welcome to multiply them out and then you'll see you come to the exact same answer. So let me go through that again. We write down the factors of the first, the factors of the last, pick those that are closer together, multiply them in your head until you found a combination that'll work to get the middle value. When you found it, write it down like a baby from left to right. 2x times 4 gave you 8. 3x times 5 gave you 15. Allocate your signs. Bring the signs to the front and put your sausage in. You got it? Let's try do another sum. 6x squared plus x plus 2 plus 7x plus 2. All right. So what are we going to do? I'll do this guy in green. We take the factors of the first, 1 and 6, 2 and 3. Factors of the last, 1 and 2. We want to get a value of positive 7. Pick those that are closest together and multiply them in your head. 2 times 1 is 2. 3 times 2 is 6. Will 6 and 2 work to give you a 7? Nope. So then I'm going to turn them upside down. I'm going to say 2 times 2 and 3 times 1. 2 times 2 is 4. 3 times 1 is 3. Will 4 and 3 work to give you a 6? Yes. So now that you found your combination, you're going to write it down like a baby. 2 times 2 is 4. 3 times 1 is 3. To get a positive 7, I need to get a positive 3 and a positive 4. That means that I'm going to bring this to the front, a plus and a plus, and then I'm going to go and put my sausage in. So I get 3x plus 2 and 2x plus 1. There's your answer. Got it? Right. Now, just before we move on, I want to remind you what we did about the easy trinomials. What we learned there was that the minus or the plus in the last position is the thing that's going to tell me if I have brackets that have the same sign or opposite sign. In my first example, I happen to have had a minus, and my brackets happen to have worked out to both have opposite signs. In my second example, I happen to have had a plus over here, and I happen to have found an answer with the same signs. So everything worked out fine. But every now and again, you find a sum where again you have an option between more than one factor pair. Okay? Let's do one of those examples now. 3x squared plus 5x plus 2. All right? We're going to take the factors of the first, 1 and 3, the factors of the last, 1 and 2, and we want an answer of positive 5. Pick those that are closest together. 1 times 1 is 1. 3 times 2 is 6. Will 1 and 6 work to give you a positive 5? Yep. So we say 1 times 1 is 1. 3 times 2 is 6. You want to get an answer of a positive 5. So it's a positive 6 and a negative 1. Bring those signs to the front so we get a negative and a positive. And then you put the sausage in. 3x minus 1, x minus 2, plus 2. Uh-oh. Do you see what happened? We have a problem. That problem is that I have a positive in the last position, which means that my brackets need to have the same signs. Do not fidget with the signs. It will not work. It means that you have chosen a pair that is not correct. And you have to go back to your original step and find a different pair. If I said 1 times 2 and 3 times 1, I'll get 2 and 3, and that will also give me a 5. So let's try that option. 1 times 2 is 2, and 3 times 1 is 3. To get a positive 5, I need a plus and a plus. Bring those signs to the front and put the sausage in. 3x plus 2, x plus 1. Do they both have the same sign? Yes, so I'm fine. My sum's right. Okay. There are very few sums that give you an option. There are very few sums where you will have a choice between different factor pairs. The one in the test is usually one of those. All right. So you have to be very cognizant of it. It doesn't happen all the time. It happens very rarely, but the one in the test usually is an option sum. Okay. Now, what I suggest you do, we're going to call this video quits, and I'll see you in the next one. But I suggest what you do is right now, before you watch the next video, I want you guys to go and practice these sausage sums. If you practice like 10 of them right now, you'll get it concreted into your head and you'll never forget it. But if you wait for 24 hours, you'll probably forget it, and then you'll have to rewatch the video to try and remember what to do. Okay? So go practice now quickly. Good luck.